All right, lesson 12.5 is called Volumes of Pyramids and Cones. Two shapes that a couple sections ago we learned how to find the surface area, so we should be a bit familiar with them. We will start out by sharing the formula for volume of a pyramid, in which V for volume is equal to 1/3. As it's meant for a few sections now, when you see a capital B, that is the area of the base. With pyramids, remember there's not really any choice at all. You will have some polygonal base, in this case it's a rectangle, and then surrounding it will be the lateral faces, which for a pyramid have to be triangles. And then the height is the h. Remember, the actual height always has to make a right angle with the base. So looking at example 1 over here, go ahead and draw this pyramid. It's got a rectangular base. I can tell it's rectangular, not square, because this side's 10, that side's 8, so they're not the same at all. And then the 12 is going from the vertex, and then it is making that right angle with the side, so that would count as our height. So plugging in, volume in this case would equal 1/3 is always the fraction. Area of the base, being a rectangle, since it's 10 by 8, we can just do 10 times 8. And then times the height, which is 12. And you can do some of that by hand. If it were me, I would go ahead and think, well, 1/3 of 12, that becomes 4. And then 10 times 8 becomes 80. And 80 times 4 would tell me the volume is exactly 320 feet. And since we're doing feet times feet times feet, it is cubed, which volume, again, always will be. All right, so if you know the base, you know the height, you'll simply plug in, and then that will provide your volume. And don't forget, the unit is feet cubed. Example 2, I'm going to be doing the same thing, finding the volume of the pyramid. So take a moment to draw this, pause if you need to. In this one, we don't know the actual height yet. So that's something we're going to have to figure out. So we are given the slant height, not the actual height. So the actual height would drop down like that. And we currently don't know that at all. So our goal is we're going to have to figure out what that height is. And I would maybe go ahead and write out the rest of the formula that we know volume is going to be 1/3 times area of the base could be 16 times 12 times whatever h is. So I'm going to leave that blank for now. So to find h, here is my thought. When I look at this, I see that I could create a right triangle within this. So if I bring that over, there's this right triangle that is standing vertically within this. And the hypotenuse of that right triangle would be the 12. And h would be one of the other legs. The other leg down here, I also know the value of, because if this entire side is 16, from the center over would be half that, so 8. So we could set up using the Pythagorean Theorem to find that missing side that would function as our height. So I would do h squared plus 8 squared equals 12 squared. Evaluate, so h squared plus 64 equals 12 squared is 144. Find the difference. So h squared is 80. And root both sides. So that's our height. Our height is root 80. And ideally, we try to only round once, so I'm just going to plug that right there. Use that as my height. And then key in the whole thing. So typing it into my calculator as I speak. So 1/3 times 16 times 12 times the square root of 80. And we'll continue rounding to the nearest tenth as we have most of the time this unit. So 572.4. And then inches cubed would be the unit. All right? So that is how you can deal with it if you are given the slant height, but you need to find volume, so you need the actual height. As long as you know the sides of the bases, if you know this side, you could bisect this one, and that's where that 8 came from, half of 16, And then we used Pythagorean Theorem to find what we needed there. If you need to, feel free to rewatch this one. Cones have a relatively similar formula to pyramids. 1/3 shows up again, and then it's pi r squared h. R, as it's been, is the radius. And then just like in the last formula, h is the height. And again, the height must make a right angle with the base. We don't want the slant height, we want the actual height when we're working with volume. So example 3, from a couple sections ago, we would have referred to this as an oblique cone. And oblique meant that it was kind of slanted over. And we said for oblique cylinders or oblique prisms, the fact that it was oblique and slanted over didn't affect how we found the volume, and that's also true for a cone. So we're still going to use this formula whether it's a right cone with the vertex right above the center, or if it's an oblique cone where that vertex is not on the center. So in this example 3, volume would equal, it's always going to be 1/3 pi times radius squared. So if we look at ours, we have the radius. 5 squared times the height, which would go from the vertex and make a right angle with the side. If it's an oblique one, typically that vertex is not going to be on top of the base. It'll be outside of it, which is fine. And then we're going to type that in and round to the nearest tenth. So 1/3 times pi times 5 squared times 27. Double check, make sure we're typing it in right. And to the nearest 110th, let's do 10th, 706. And then I've got 8.5, so I would round that up to 9 meters cubed. Okay. So that's volume of a cone, 1/3 pi r squared h. Like example 2 for the pyramid, we won't always just have what we need. So example 4, we're going to find the volume of a cone. So again, it's going to end up being V equals 1/3 pi r squared h. But if you look at this, we have neither thing that we need. The radius was not given to us, and the height was not given to us. So I'm going to do two things. I'm going to draw both of those in first. So my height would be that. I'm going to label that as h. And then my radius, I guess I do already know, that would be the radius. And how I could get the radius would be taking the 15, which would function as the diameter, and dividing that by 2. So our radius will be 15/2, which we can just write as 7.5. So I can put that right there. Then I can use the 7.5 to find my height, because we were also given this angle was 61. Bear in mind, it's not actually 60, so you cannot use the rules for 30, 60, 90s, because it's not exactly 60. So we would rely on which trig function would fit. So looking over this one, compared to the 61 degrees, the h would be opposite. And compared to the 61 degrees, the 7.5 would be the adjacent. So if we think back to SOHCAHTOA, we would look for which one of these utilizes the opposite and the adjacent. So it's not sine, it's not cosine, it's tangent. Opposite and adjacent. So my setup for that part would be that the tangent of our angle, which was 61 degrees, would equal the angle's opposite, which we have labeled as h, over the angle's adjacent, which we have labeled as 7.5. And then we just want to get that by itself, so I'll multiply that over. And that is my height. So now I'm ready to type everything into the formula. So our volume will equal 1/3 pi times our radius, which was our 7.5 squared, times our height, which was 7.5 tangent 61. And I would just type all of that in at once. We've got 1/3 times pi times 7.5 squared times 7.5 tangent 61. And if we key that in correctly, we should be getting 797.0 meters 10, and that would be centimeters cubed. A reminder with this as well, whenever you're working with trig, like sine, cosine, or tangent, if your calculator's been reset or somebody else has used it and you're not getting 797.0, but you're pretty sure you're typing it in right, you might need to check your mode. And since our values are in degrees, you're going to want to make sure that it's set to degrees and not radians. So again, if you're typing this in correctly, but you're still not getting that number, it might be a good idea to check the mode on your calculator and make sure that that is set correctly. And that does it for this lesson. So things that you will be practicing on the assignment, you're going to be working with pyramids first of all, which 1/3 area of the base times the height. The base will always be whatever polygon is down there, not the triangles going around it, but it could be any shape. It could be a triangle up to any number of sides. And then the height that you're after, again, is the one that goes from the vertex, makes a right angle with the base. If you're not given the height, then you might need to create some kind of triangle within this and make it work. Okay? So within these, you'll be able to make right triangles very easily because all those lateral faces are triangles as well. So don't forget how we got the 8 there was we took the 16, we divided it in 2 because that was bisecting it there, and then we did the Pythagorean Theorem. Cones, whether they're oblique or not, it's 1/3 pi r squared h. Again, the the height has to make a right angle with your base. And like we modeled on this one, we could use some trig to figure out what that was. So if you need to watch anything, feel free to do that. Otherwise, spend the rest of the block working on this assignment.